Hey guys, Miss Fearing here. Welcome to Unit 3, Notes 3. Our learning target today is I can multiply monomials. So before we go ahead and move on to anything, I really want you to understand what a monomial is. A monomial is a number, a variable, or a product of a number and more than one variable. So all real numbers, constants, all those things are monomials. So we could say 3 is a monomial. 3x is a monomial. 3xy is a monomial. All of those different things are what we're going to talk about today. So we're going to start off by looking at some rules of these exponents. And there's 3 different ones we're going to focus on today. The first one we're going to focus on is the product of powers. Remember, product means to multiply. So when we are multiplying powers, we are going to add the exponents. We want to add those exponents. So the example we have here is a to the 6th times a to the 3rd. So the exponents we're going to add, so I'm going to get a to the 6th plus 3, which is going to give me a to the 9th. Okay, so when we multiply, we add the exponents. Power to a power. That means when we have 2 little guys next to each other like this, 2 exponents next to each other, that's going to be a power to a power situation, and we are going to therefore multiply the exponents. So when we have this, everything in this set of parentheses is squared. So we want to go ahead and we want to write 6, well, this is one way we could write it, 6a to the 6th times 6a to the 6th, which then brings us back up to a multiplying situation. So we would get 6 times 6, which is 36, a to the 6th plus 6, which give me a to the 12th. Another way that we can think of that is this 6 has an imaginary 1 as an exponent, so this is where we do our multiplication. We kind of distribute that idea. So I get 6 squared, and then a to the 6th times 2 gives me a to the 12th, which then I can know that 6 squared is 36, a to the 12th. So it's the same idea, you're still going to get there either way. The last rule that we're going to look at today is the 0 power. Anything, no matter what it is, anything that is to the 0 power is going to equal 1. It equals 1. So this whole thing right here is to that 0 power, so my final answer is just 1. So a question I get a lot of the times is, how do I know I'm done with the problem? So you know you're done with the problem when each base appears exactly once. You have one x, you have one y, you have one coefficient. When there are no powers to a power, so you don't have 2 exponents next to each other, and then when all of the fractions are in simplest form. If you have all those 3 things done, then you know you are done with that problem. So let's look at problem number 1 here, example number 1. Anytime a base does not have an exponent, you have to remember that it is imaginary 1 up there. It's not a 0 because then it wouldn't be there. It is an imaginary 1. So right now, I only have one coefficient. I have 4. That's going to stay there. I have an x to the 1st times x to the 2nd, which is going to give me an x to the, when we times, we add them. And then I just have that y to the 3rd. So I'm just going to go ahead, final answer then, add that 1 plus 2, which gives me 3, and everything else is just going to carry down. Example number 2 then, we want to multiply the coefficients. These are not exponents, so we don't want to add them. We only add the exponents. So multiply the 3 times 2, so I get 3 times 2. Now my x's, when I multiply, I add, so I get x squared plus that 4, and then this y has an imaginary 1, so I get y to the 1 plus 8. So I'm going to have 6, x to the 6th, y to the 9th. And that would be my final answer. I'd be done. Now, example number 3. This is where it becomes my favorite examples here to do. Anytime you have anything to the 0 power, so this whole thing is to the 0 power, my answer is going to be a 1, and I'm done. looking at example number 4 then, this is the only thing that's to the 0 power. So this whole thing right here is going to become a 1. But that still means I have the 6x to the third y over here. So 6x to the third y times 1 is still going to give me 6x to the third y. I only have one coefficient, 1x, 1y. I'm done. So number 5 here, this is where I start to run into those power to a power situations. And I know that because I have two coefficients next to each other there. So I'm going to go ahead and I am going to write a coefficient in, or an exponent in for every base that I have. So the 4 is going to be to the 1, the x is going to be to the 1, and the y already has an exponent, it's a 2. So now when I have a power to a power situation, I'm going to multiply these things, and everything inside of it gets that multiplication. So I'm going to get 4 to the 1 times 2, which is 2. X to the 1 times 2, which is 2, and y to the 2 times 2, which is 4. So 4 squared is going to give me 16. I have the x squared, I have the y to the 4th, and I'm done. Another way you could have thought of that process is this exponent out here tells me I have 2 of those inside things. So I have 4xy squared times 4xy squared. So I can then multiply, and when you multiply, you add. So I have a 4 times 4 first, and then I have an x to the 1 times x to the 1, which is x squared. Y squared and a y squared gives me y to the 4th. Notice how those two answers are exactly the same, so it doesn't matter which way you look at doing that problem. I want you to go ahead and try example number 6. So pause the video, try it, and then come back and check your work. So when I went into this, I got 16x to the 4th, y to the 4th. If you didn't get that, please come talk to me before moving forward with the notes. So for number 7, 7 is telling me I'm multiplying. So when you see two parentheses next to each other, we're multiplying those things. So I still have that 5, and then when I multiply, I add the powers. So I'm going to end up with x 7 plus 6. So my final answer is going to be 5x to the 13th. Number 8 is the exact same kind of way. I have a 4 times a negative 7. So I get a negative 28. And then I have to add the powers. Remember, if there isn't a power there, it's an imaginary 1. So I have a to the 1 plus 2 and b to the 6 plus 3. So I get a negative 28, a to the 3rd, b to the 9th. I know I'm done because I have one coefficient, one a, and one b. I am good to go. Okay, example number 9 has multiple steps to it. So we're going to take this piece by piece. We want to get rid of this power to a power first. And when we do that, we multiply. So 2 times 3 tells me I have a 6 there. So now I'm going to have 3xy to the 4th times a negative 2y all to the 6th. So I want to work on my outermost number first. So I'm going to go ahead and I'm going to work on this first. I have that 6 going to each thing inside. So I'm going to end up with 3xy to the 4th times negative 2 to the 6th y to the 6th. Now I want to simplify that negative 2 to the 6th. So I'm going to go ahead and I am going to do that in my calculator here. Remember, when you plug that in, you want to do negative 2 in parentheses and then put it to the 6th power. So I'm still going to have the 3xy to the 4th. And now that negative 2 to the 6th, I got 64 y to the 6th. And now we're multiplying. So I'm going to do the 3 times 64. X to the 1, when we multiply, we add the powers. I don't have any x's on the other side, so I just have x to the 1. And then y to the 4 plus 6. So I'm going to end up with 192 x to the 1, y to the 10th, and I'm done. Last example here, we want to go ahead and we want to express the area of the square as a monomial. So basically we want to find the area of this square here, and I know that area is going to equal length times width. So in this situation I have area equal to 4AB times 4AB. Now you just have to remember these are all imaginary ones here, and when you multiply you add them. So I know I'm going to have an a squared and a b squared. I just have to remember these are not exponents, so we don't add those, we actually multiply them. So 4 times 4 is going to give me 16. And then I'm going to go ahead and I'm going to label this, because we are talking about area. It's going to be a unit squared, and we are done. Go ahead, try the practice for today. If you get stuck on anything, please come over and chat with me.